on okay. So good morning or good evening, depends on your time zone. So thanks for participating in this webinar and hoping this coming hour will be valuable for you. So first, let me introduce myself. I am Mu'taz Kamel, 30 years experience in oil and gas, geophysicist by background. Worked as a starting climbing the ladder from through my career from a junior geophysicist up to exploration manager. Um, I'm a former exploration manager in a multinational company, and also a former APG vice president for Africa region. So today we will explore the role of geophysics in the business decision from the frontier exploration to the life of fields. And as we will see across the slides that geophysics is taking a big role in our understanding of the full basin. So next slides. So geophysics tools, seismic, gravity, or magnetic, are the main and maybe the only tool representing the basin as a large subsurface data volume. There is no discrimination for the role of geology and well data here, because geology and well data are a key data for our understanding the basin. But when we are talking about well data, it's just only representing just this small cylinder around the 6-inch hole or 8-inch hole. But the geophysics or the seismic and gravity and magnetic are representing the full subsurface basin across the whole area that we are exploring. So let's talk about something like the reservoir. Reservoir at the well location, we can detect the reservoir characteristic at the well location. But few meters away the well, the reservoir could be changed, and the behavior of the reservoir could change. It could be disconnected from another reservoir or another channel. So the only tool representing the whole subsurface is the seismic, and is used to understand this change. So another example, like the tectonic and the structures. We may not detect any, or we may not see any fault in the well, but just a few meters away from the well, the seismic is the key. Gravity and magnetic is the key here. So that's why gravity or the geophysics, seismic, gravity, and magnetic are representing the value of information that we are looking for here for our business decision making. So the objective here is of that hour is we need to look for the impact of value of information of geophysical data on our business decision making across the whole exploration and production value chain. And also the impact of the geophysical data on helping other multifunction disciplines in making their decision. So something like wells, reservoir engineers, facilities, all those multifunction disciplines, we will take a look for how geophysics is helping them. So our agenda today is, first, we will introduce the role of geophysics across the E&P, exploration and production value chain. During the operation, seismic operation, technical versus business. Seismic operation is not just putting the crew vessel in the field to acquire data, but also there is a business behind it, a business decision, and there is a value and impact. And when we say a value impact, this means cost, this means time. And this is what we will take a look for it. We will also, within our slides, we'll take a look for the multidisciplinary geophysics output. And finally, we will wrap up and we will have your questions Q&A. So let's have a couple of slides here to take a look for and introduce our geophysical techniques. So we will have some refresher about geophysical techniques, geophysical applications, and also the E&P, exploration and production stages, before we will go through our slides. So first, let's go for around our geophysical techniques. So we know that we have 6 techniques that we are used: gravity, magnetic, electromagnetic and electric, seismic reflection, seismic refraction, and vertical seismic profile, or the VSP, which is the inside the well. So gravity, we are using the gravitational force of the Earth, and we can see the bird structures and any geological feature. We can see it from the gravity. Magnetic, the same. We can delineate the mineral deposition. We can delineate the main structures through measuring the magnetic field of the Earth through susceptibility. Electric or electromagnetic, we are measuring the conductivity of the Earth, looking mainly for hydrology or water, or also the minerals. Seismic reflection and refraction, we are looking for subsurface structures. We are looking for formations. We are looking for different rock layers. And finally, the VSP, or the well logging. We are looking inside the well and measuring the rock properties inside the well, which is the most detailed velocity that we are getting from the well, which is completely different, a little bit different from the seismic reflection, but it's correlated to the seismic reflection, so we can correlate the velocity from the vertical seismic profile. Applications of geophysics. So we have different applications. We are just giving here few examples. Energy sector. So we are looking for oil and gas through exploration, production, and reservoir management. We are looking for mining industry. We are looking for mineral deposits, looking for any ore minerals. Civil engineering. This is where geophysics is used for site characterization, foundation design, risk assessment for construction projects. Archaeological research. We are looking to find sites, graves, individual structures for archaeological. Groundwater resources, where water is present, and the quality of water, even the quality of water, we can evaluate the quality of water. And finally, the environmental remediation. Any buried debris or objects of concern, we are using geophysics to use and map it, to map those objects. So geophysics is not just only oil and gas. We are using geophysics across all our life here. Now, if we will focus on from those applications, we will just only focus on the energy sector, which is the oil and gas exploration and production, what we call the E&P part. So E&P introduced the energy sector in oil and gas. So introducing the energy sector in oil and gas, we have 3 stages. We have the upstream, where we have exploration, development, and production. We have the midstream, and we have the downstream. So the upstream, it's mainly looking for searching for the hydrocarbon, exploring the basin, drilling, developing, and extracting up to the depletion. So for oil and natural gas. Midstream, it's about processing, what we defined, storage, and transportation. And this include all the companies that specialize in operating tankers, ships, pipelines, or storage facilities. Finally is the downstream, and it's about refining, distributing, and retail of the petroleum products. And the downstream industry provides numerous products such as jet fuel, gasoline, diesel, synthetic rubber, plastics, propane, natural gas, pharmaceutical. So it includes the distribution of all the products that it's coming from the hydrocarbon, is or either oil and, or gas. So for our discussion today, we will mainly focus about the upstream, which is the exploration, development, and production. So we call it the EMP, energy EMP value chain, because it's called the exploration and production. And it consists of, here we have 7 stages, from access up to the dilution or divesting, or as we call the depletion of the finding. So we have here 7 stages, and this is what we call, this is maybe the most detailed version. There is a lot of versions for the EMP. Some of them are merged together. Some of them are, some maybe 2 stages are merged, or 3 stages are merged together. It ranged between 5 stages to 6 up to 7. So 7 is the most detailed version. And this is what we are talking about here. And the reason we are taking that because it explained each one of them in details. The whole value chain, it's about, as we said, searching for the potential underground or underwater crude oil or natural gas, drilling the well, bringing that hydrocarbon or the finding to the surface until the depletion. So we have the, let's say, let's start with the access. And this is, let's first talk about those stages in details in the next slide. So let's introduce first the scale here. So we have a time, which is the we have the horizontal scale, and the horizontal scale represent here the time across the whole value chain. And we have the vertical scale, which is the production. Let's first go through each one of them and understand what's the role of each one of them. So the access, this is when we are looking for the right opportunity that meets the investor agenda. And when we say that the investor agenda, because the investor agenda has his own business decision, and that agenda has to meet or to match the opportunity that we have in the area that we are looking for. If we will have the right area, we'll start to explore it. And explore it, this means that we are looking for the right play, discover it, appraise that opportunity, and then we will go to develop. And development means that we'll start to look, is it the right opportunity to develop or not? Then we will start our production. And this is where we'll start to what we say to produce. And this is, we have a ramp, and then we will have the plateau, and then we will have the decline. During the plateau, we will keep infilling our resources with more wells to keep the plateau steady. And then we will start, and after a certain time, that field starts to decline. what we call it the early or late decline. Across that, from the develop up to the end of the decline, this is when we will start to look for the potential project is funding required, starting from the development part. Once we will start the production, this is when the high capital spend start, because this is actually the project started. Once we are in the plateau, this is when we'll start to generate cash. And then, and the close to the declining, the project is self-financing. When we'll come to the decommissioning, this is the cash sink, and this is when we'll start to dilute, divest, or we'll start to deplete the prospects. So let's start from the access, how the physics is working here. So going behind the amplitude and frequency and mapping the structure, we need to create an information that is relevant for the business decision along that value chain. So if we will start with the access, so starting with the access, which, as I mentioned, reflects the formulation of the investor strategy and the opportunity to capture. In that stage, maybe the only data available in the basin or in the area of interest could be just only gravity, magnetic, and maybe a couple of seismic lines. We may not have any other data. We may not have wells. We may have some surrounding geological information, surface geology, but we may not have subsurface geology because we don't have any wells. So at that time, the geophysics is the only tool that will be used here to make our evaluation. So that data should be used and squeezed up to the last drop to get all the information to understand the basin shape and build a robust technical opportunity with other disciplines like wells, reservoir engineers, facilities, and commercial. So using gravity, magnetic, and seismic, we have to build up our structure, knowing what are the opportunities. Do we have a running play or running room? Do we have different plays, or it's just only one shot opportunity? Using that data, and after we can start giving some information to the wells. Using the seismic data, we have velocity. We can convert velocity to pore pressure. We can, using the seismic, we can start look for the reservoir, giving it to the reservoir and giving some description to the reservoir engineer, where we are from the shore or where we are from near infrastructure. So we can give and we can calculate the volume. We can give that all to the facilities engineer, and all that is going to the commercial, so we can understand, is it a commercial area or it's not commercial area. Based on that, the business decision will come up with go or no go for the access. So the seismic here, or I would say the geophysics here, is the only tool used to make our business decision. Going to the next opportunity, or to the next one, which is the explore. Once access is complete, exploration is to acquire the right seismic program. And when we say the right seismic program, because we may not use the highest technology in that phase, we need to look for what is fit to purpose within that stage to use for the full basin evaluation with the right acquisition parameters based on the level of exploration. And when we say level of exploration, we have here during the exploration phase The area that we are exploring could be either renewal area, core exploration, or ILX. Renewal, it means a new basin, frontier basin. We don't have any information. It's no one stepped in that basin before. So that's why we have to have a full understanding of the area before we go for drilling. And we'll need to know that is the area is the right place to continue or not. So renewal, we have to select the right program for that area, for that exploration phase. Core exploration, we may have some discoveries, but still more discoveries are coming. So we may change the level of seismic program. We may change the level of acquisition parameters. So all that needs to be worked across the area while we are working. ILX, which is called, and I have here all description in the lower right corner of the slide. So ILX is the infrastructure-led exploration. And this means that we have already infrastructure in place, and we are doing exploration around that infrastructure. So at that time, do we need to acquire more data, or do we need more just only processing? What type of processing? What type of seismic program? Is it a high resolution? Is it a new technology? So based on our exploration phase, we will select the seismic program. We will select the right acquisition parameters. With the full integration of the geological study of the area, we will come up with structure, stratigraphic definition, and we will come up with a basin analysis through acquiring either 2D or 3D data. We will, in the next few slides, after a few slides, we will take a look for what are the type of 3Ds that will that could be acquired. Within that stage, the geophysical information is the only tool for the wide subsurface basin to understand the subsurface basin and understand the hydrocarbon location through structure and stratigraphic definition, through repeating again the same technical evaluation during the access phase, which is looking for using the seismic to come up with the velocity, which could be turned to pressure, could be turned to depths, so we can give to the drillers a well prognosis in terms of depths, in terms of pressure. We can give from the reservoir engineer how could be the reservoir definition and extent of the reservoir. The same for the facilities. We can calculate the volumes, and we can, at that time, and also where we are from the facilities, or do we need to build facilities? How big the facilities based on the volume that we will find from the seismic. So reservoir facilities engineer can design their facilities, and all that will go finally to the commercial to build an economic value here. So when we look for the access, explore stages, we are repeating the same cycle every time. And finally, the end of the cycle is usually we are looking for the economic value here. Do we continue or do we stop? So technical only is not the answer, but it's the whole value chain together, all the disciplines together that are giving the answer, do we continue or not? Is it an economic value to continue or it's not? Exploration phase is concluded with drilling. For the right quality prospect, first, to reduce uncertainties within the area, and also to de-risk the main subsurface risk here. After we've come up with a discovery, or once discovery is in place, the decision will be either to move directly to the development, directly from the discovery to the development, or we go from the discovery to appraise. Decision, to make that decision, we need the geophysical data here because we are creating the right attributes, helping us to either go directly to the appraise or directly to the development through creating acoustic impedance volumes, lithology impedance volume, fluid impedance volume, through the DHIs, through the AVOs, to understand the reservoir and to have the right business and financial decision. Also, we have to put in mind, if we will go directly to the appraise, this will improve our project profitability, but we will make late for our cash flow. While if we will go directly to the development, we will create an early cash flow, but we may have a risk for our funding volume. So because the data that we have in hand may not be enough to come up with a volume. Based on that, facilities engineer could design a facilities either bigger or smaller than the finding. Based on that, either we will spend more money or less money that we may not be able to produce enough because the facilities is smaller than the finding. So, but we will create an early cash. So it's not easy decision. Geophysics, I will say, is maybe the only tool in place using the well, which is just only one point in the basin, and the seismic will be used away from the taking it away from the well location to the wide basin to make that decision. So after the discovery, either to go to appraise or proceed with development, or we may come up with a decision, stop and sell the finding because it's not commercial. Again, the decision for any one of them, it's not from the outcome of the well, it's the combination between the outcome of the well and taking that outcome extended away across the wide basin through the seismic data. So which means that the geophysical program, either conventional or any type of technology that will be used, need to tie to the full depletion plan. It's not about the seismic that we are acquiring now, and it's just only for that stage, not just only for exploration stage, not only for the appraisal stage. It's a seismic that will tie to the full, that has to tie to the full depletion plan up to the end of the production. The selection of the right activity has to feed the business decision. And this is through the value of information that we are collecting and through fit to purpose. And we will have later on a slide talking about those two value of information and the fit to purpose program. Moving to the development and production. In this process, we have, during the development, we have three processes has to be in place, or decisions. We will say three decisions has to be in place. First one is the field investment decision. Second one is the field development plan. And the last one is the front-end engineering design. Those three decisions has to be in place during the development phase. And based on that, this is when we will decide to go ahead with the project or not. And this is when we will start to put the finding required for that project. How we are putting all that? We are using the seismic, either through acquisition or processing new technologies. That seismic will help us for reservoir development and fluid contact and movement through resolution, net pay seismic, static and dynamic reservoir models. So we are building a full reservoir characterization model, static and dynamic, from the seismic to understand our reservoir, to understand our fluid contact and movement. We may acquire new technologies like the time-lapse seismic 4D, which plays an active role in that decision through the for reservoir and flow surveillance. So during that process, during that phases, development and production, we will use the geophysics for reservoir description, integration with well data, detect the reservoir heterogeneities away from the well location, how it's impacting the reservoir surveillance, building the static and dynamic reservoir model, fluid contact, movement along the production time, study and driving the force of the reservoir, the contact move and pressure change. So let's ask the question, how we will see the pressure change. We have just only one well. We will not measure the pressure because we are still in the exploration, or maybe in production we can measure. But during the development itself, we need to see the contact. Seismic is the only tool to use the contact. Pressure change, we can convert velocity to pressure, and we can see how the pressure is changing across the reservoir. How the contact, either we have different contact within the reservoir or not. This is through the seismic. So the geophysical data contributes to the reservoir economics through adding reserves, by identifying reserves that may not be produced by the existing development plan, through lowering the cost, minimizing dry holes, poor producers, and also we can have an effective infill drilling plan. So we can see through the geophysics data, we can build a robust reservoir characterization. We can reduce our dry hole. We can make the infill drilling plan much better. And also we can add reserves, not only within the reserves that it's under production, but also that the one that it's not within the development plan. So based on that, geophysics tool contribute to the reservoir economics during any phase of the E&P value chain process and last for the life of the reservoir. So when we take a look for the tools, we need to understand what are the tools of seismic that will be used or could be used. So in order to tie the geophysical technology to the full value chain up to the depletion plan, to select the right program, we need to understand the different types of surveys. Any seismic program, as we all know, is looking for enhancing the seismic quality. So any seismic program is looking to enhance the seismic quality and to improve signal to noise ratio. And this is through azimuth and frequency. One will talk about here, so seismic and azimuth and frequency. During the course that it will run in full detail for that webinar, we will discuss very detailed the role of azimuth and also the role of frequency. Here, just only let's talk about the azimuth first. So the azimuth, we have surveys coming from narrow azimuth, we'll call it NAZ, narrow azimuth geometry, up to the phase or the full azimuth geometry. And this is based on the objective. So narrow azimuth, and we can take a look for the description along the whole different geometries from NAZ, which is the narrow azimuth, multi-azimuth, wide azimuth, and full azimuth. Each one of them, we are increasing recording azimuths. So just the narrow azimuth is just only a single azimuth across the whole Rose diagram of the acquisition geometry. The multi-azimuth, it's the same as the narrow azimuth, but adding different azimuths in different direction. WAZ, or the wide azimuth, it's a wide azimuth, so we are including more azimuths or a wider azimuth within the direction of shooting. And finally, the full rich azimuth, it's the full Rose diagram geometry. Across the four of them, the main target is improved target illumination, signal to noise ratio content, and resolution. How to enhance illumination, and how to enhance the signal to noise ratio, and how to make the resolution much better. The selection of that, it will be discussed more detailed in our detailed course. When we will have the selection of the azimuth, we also have what's called the frequency or the broadband. And the broadband is looking for the full frequency, capturing the minimum and high frequency, the low and high frequencies during the acquisition. And the reason for that is to improve the resolution of the subsurface, improve the imaging, and allow for better understanding of the rock properties. We can acquire multi-azimuth with a broadband. We can acquire full azimuth as a broadband. So broadband, we can acquire it as just as a normal broadband survey, not as a normal survey. And also we can acquire any of those azimuths or multi-azimuth program combined with the broadband. But here we need to look, when we are looking for that, we need to look for the cost versus the output value of the project. So we are not looking here just only for the best of the best technology. We need to look for the cost of that technology versus the output value. Is it valuable within the stage? And when we will take a look here for is it valuable within the stage of the value chain? Do we need to acquire a full azimuth during the exploration phase? Or do we need to acquire it within the development or production phase? This is the selection or fit to purpose or the value of information that we will take a look for in a couple of slides. So once we will select the right program and we will go for the operation, this is also creating a value, which is the cost or time or opportunity, which again is a cost. So during the operation, we have a triangle of three main elements. We have the top of the triangle, is the HSSE, which is the health, safety, security, and environment. And why it's at the top of the triangle? Because it's the first priority for any operation. Not having the right seismic safety planning could lead to incident or facilities, either in the workforce or in the equipment, which could affect the progress and survey timing, which is reflected as cost and timing for the opportunity. So any delay or any misplanning with the program, it could cost us more money. Technical, which is the other part of the triangle, this is the key to reduce the uncertainties, and it's actually impacting the business decision based on the output data. When we take a look for the area or the area between the triangle or the common between the technical and the HSSE, we have to look for the survey area, any obstacles in the survey area, subsea facilities, that the equipment could be affected during the survey. So if we are on land, onshore, and we are acquiring seismic, what are the obstacles that we have? Are we stepping inside a city? How we can make the place safe during the operation? So technical is not just only by itself during the operation, but actually it's combination between both of them. The third part of the triangle is the contractual part. And why the contractual? Because it's the main controller and the main deliverer of the project, and it's handling the projects with all other disciplines. If we take a look between the technical and contractual, what are the survey objectives? This is stated within the statement of requirements in the contract. Acquisition parameters is stated in the acquisition contract. So the contract is actually the main controller between the technical and between the operator of the survey. Between the contractor and the HSSE, actually, we have to conduct audit. We have to look for the management system. We have to make and make an audit for the management system. We have to make an audit for the company that is acquiring the survey. While we are doing all that, we have to make sure that who is coming to run the operation has to be up to the standard of safety to run an operation without any incidents or fatalities, without any delay in the project, because any delay is a value, and the value, time is a value, cost a value, losing the opportunity is a value. So seismic operation is both technically and commercially, because it's impact and solve the business problem, fit to purpose. The project or the program has to fit to purpose to solve the business problem. Deliver the required data to support the business case. If we are not choosing the right contractor, we may not get the right data. If we are not choosing the right acquisition parameters, we may not get the required data to support the business case. Delivering the right data to reduce the technical risk and the uncertainties of the subsurface. Support planning and execution of the exploration or the appraisal stage and help deliver early and sustainable production. This is what the seismic program should be used for. Finally, delivering a safe project with no harm to people or the environment, and deliver projects within the proposed budget. Because again, if we are spending more money, this will affect the commerciality of the whole project later on. So saving the project along the seismic operation triangle represent the value of time, cost, and opportunity. We had been talking about value of information, value of information. So what is value of information? Selecting of any seismic program or technology should be the right program to create significant value of information that is relevant to the business decision. Usually ask the question, is the seismic data relevant in order to reduce risk or not? So the right selection of the seismic program should be how accurate to detect the geological outcome, how to reduce uncertainty and risk, is that data is reliable, and what does it mean reliable? That has that it's we can see high resolution, and we can see high signal to noise ratio. Usually ask the question, is that data is relevant? What does it mean relevant? If the seismic technique used during the exploration phase, during the E&P phase, either exploration, appraise, or development, is non-unique, at that time it's not relevant. And if it's not relevant, it's not reliable at that time. And what does it mean not reliable? It's not a good resolution and doesn't have the good signal to noise ratio to solve the signal for that stage, either exploration, appraisal, or development. So spending time and dollars with non-reliable data will not help neither the technical or the business. So using seismic value information tool through decision analysis flowchart. So we have here what's called a flowchart, and we are using the NPV, net present value, with percentage of success and failure across a flowchart. We use it to come up with a value of information for that project. And that value information, we will have a very detailed understanding of how to learn to calculate the value of information during the full course of that webinar. And we will have a lot of examples of how to calculate the value of information. If we will have the right data, so now we can make difference in the NPV of the outcome. And based on that, ultimate distribution of the outcome. If the data is relevant, at that time we are using the right data or fit to purpose, not spending a lot of money with a very little impact on decision. This is what's called the fit to purpose tool. And again, we will have a very detailed description of fit to purpose method during the full course of that webinar. So saving the project by eliminating an unnecessary dry hole is as good as drilling several successful wells in terms of NPV. So this is exactly what we are looking for, is to drill success wells and save the project's unnecessary dry holes through selecting the right data, selecting reliable data, relevant data that has that make a difference in the NPV of the outcome. So let's have a look now for how geophysics create significant information that is relevant and suitable for business decision through quantification the economic value of geophysical information. Actually, the output of geophysical work, as discussed, is the main driver for any business and financial outcome. Outcome from reservoir characterization, reduce the cycle time for appraisal and development planning. Outcome from fluid contact and movement and static and dynamic models using geophysical data is the key to reduce uncertainty for resources and reserves estimation, leading to use geophysics in the what's called the PRMS system or reporting. What is PRMS? Is the Petroleum Resource Management System. So now geophysics is used as a tool for the resource management, for resource management system and resource reporting. Using reliable data is the key to improve drilling success rate, reduce dry hole, better well placement for flow rate, rejuvenation of the old fields and or the old fields and declining profile. All those info with quantification of the value of information will impact our economic valuation. So based upon that, geophysics became a business tool that investors uses to report reserves through geophysical value of information, to assign values to companies and to projects, which is important to the stock market and financing the projects. So we can see here that with the data and the value of information and the right geophysical program with the right geophysical parameters, we can improve our drilling success, reduce uncertainties, report reserves, impact our economic value, and based on that, investors are using the geophysics as a tool to report reserves and also to assign values to the companies and projects, which is finally a stock market and finance for the project and also for the companies. So let me take here an example from mining exploration and see the value of information. So starting at the start of the 20th century, surface prospector accounting, which is the surface geology, accounted for 70% of the discoveries. After developing of the geophysical technology, it plays an important and increasingly important role in exploration and discoveries. In mid-70s, geophysics and geochemistry techniques contributes to about 40% of the discoveries. However, in the 21st century, the geochemistry declined and diminished in the recent years with the development and use of the new geophysical technologies, which will be the more dominant tool for mineral exploration with drilling of those mineral exploration. So currently, as we'll see here, since 1950, geophysics accounted for around 22% of all the discoveries, which is a quarter of all discoveries is contributed by the geophysics. And this contribution will increase with the increase of or with the progress in geophysical technologies. During the course, as I mentioned before, there will be more analysis and statistics for the role of geophysics, like the role of DHI. And we will take a look for some statistics of how DHI increase the commercial success rate for worldwide discoveries. How AVO also is increasing the commercial success rate for worldwide discoveries. So we will talk about all those analysis during the full course. We shouldn't exclude the AI and ML, AI, artificial intelligence, and the machine learning. Because with the current speedy advances in the technologies, AI, or the artificial intelligence and machine learning, are used for most geophysical stages, either acquisition, processing, and interpretation, to improve the challenges in either exploration and exploitation, which is appraisal and development. So in acquisition example, drone-based geophysics is rapidly evolving field that leverages the capabilities of unmanned aerial vehicles to conduct geophysical surveys. So there is now currently drones are mounted with gravimeter and magnetometer to acquire gravity and magnetic surveys. This is a advantage and giving a valuable greater efficiency and cost effectiveness for the survey. So instead of coming with a plane and mounted with the gravimeter or magnetometer, we can mount it to a drone. We have very precise line spacing. We have more accurate, more close to the surface, to the Earth's surface. So it will be more professional and more valuable, and we can gather more valuable data. So this is in the acquisition. In the interpretation, in 2011, CGG has launched a geo software which includes enhanced cloud and machine learning capabilities. These new techniques, or new technique, is emerged for reservoir characterization and petrophysical interpretation using machine learning capabilities, linking geophysical, geological, and petrophysical interpretation for optimum workflows. Joining the industry solution like JSON, Hamster Russell, PowerLog, Grok SI, Insight Earth, Val Pro are all integrated all together, so they can work together on a single platform, running on a cloud platform, allowing the geoscientists to release the full power of cloud computing to explore more scenarios, generating tens to hundreds of geostatistical inversion models. This is the power of the machine learning that will be more and more developed in the coming days, not years. So let's move to the last part of the agenda, which is the multidiscipline geophysics output. And now we will talk about the role of geophysics with multidiscipline functions. The main output from geophysical data are, as we will see from here, seismic velocity, reservoir seismic resolution, reservoir characterization, structure, and stratigraphic interpretation. This is what are the output from any geophysical work. Each is giving a list of products that are of main help for other disciplines. So let's look for the seismic velocity. What is giving us? Giving us depth conversion and well seismic tie. Depth conversion is converting the we can converting seismic to depths. How that it's affecting our data. So if we'll take a look for the graph for these two synthetic models, we time migrated with 110 velocity and time migrated with 90% of the velocity, we'll see that the structure is not the same, which means volume is not the same. And if the structure is more steeper, how that is affecting the stability of the structure, or the how that will affect the borehole stability because of the stresses coming from the structure. So all that we are calculating from the velocity. Velocity we can convert to pore pressure. So we can come up with the pore pressure across the basin, and we can give the drillers where they can stop for casing before they hit any high pressure, where they can face losses. During the or within our evaluation, we can understand the seal capacity of from the pore pressure. Is our seal is good enough to seal what's below it or not, based on the volume, based on the velocity. Seismic resolution. If we have the right seismic data, as we mentioned before, broadband or conventional, can we image the reservoir thickness or not? Not imaging the right reservoir thickness, this could lead to the lower estimating our resources, or higher estimating our resources. Reservoir characterization, the same. Can we see the flat spot here? As that in that example, we can see two flat spots. Oil gas contact, we can see two contacts, gas oil contact and the oil water contact. Can we see that on seismic or not? If we couldn't see it, how we can describe our reservoir, how we can describe our source rock and our seal. And finally, using some of the attributes for compartmentalization, connectivity. So something like that channel, we can see that channel is connected, but maybe that channel is not connected to that channel. So here we can see compartmentalization, or if there is a fault between that channel and that channel. So this means that we have a compartmentalization, or we don't have, or we have a connectivity, or we don't have connectivity between the channels. So all that we are getting from the seismic. So as we said before, we come up with from the seismic velocity, from the resolution, we come up with the casing point, wellbore stability, pore pressure prediction, and fracture gradient. From the reservoir, from the resolution of the seismic, we come up with the shallow hazard, seabed evaluation. At the shallow hazard, we can see is the first section, first second of the well where we are drilling without any riser, without any BOP. Can we see any water? Can we see any hydrates? Can we see any high pressure zone? To avoid that, so we need a high resolution seismic. So again, as I mentioned before, fit to purpose data, value of information are the key for all our data here. Based on all these output, we can have a resource estimation during the exploration phase, or we can have a reserves calculation during exploitation and field development. All those data, we can, with the help of all those data, we can build up our production profile and plateau. We can build our facilities and pipeline size. Reservoir engineer, that all that are given to the reservoir engineer and facilities engineer. All that are given to the commercial, where they're using for the business decision across the whole value chain, when we need to stop, when we need to continue. So if we are in the exploration phase, using the seismic across that chain, and based on the business decision, do we need to continue or to exit? So in order to wrap up, we found that integrating geophysics with business strategies, we can identify high potential or exploration targets, increase efficiency of exploration programs, reducing our exploration risk, reducing our likelihood dry holes, reducing our finding cost, leading to a cost saving for the project. With that, we are increasing our resource estimation and reserves reporting, improving our economic viability, and increasing the profitability of the project, which by leading to increasing the stock market of the project or of the company. So as a summary here, we are not talking about geophysics as I mentioned before, amplitude, frequency, and structure. We are talking here about the geophysics. It's about profitability, economic viability, and stock market. Thank you, and ready for your questions.